Hello and welcome to another video. Today we will be talking about rates of change in linear and quadratic functions. First, let's look at a linear function. For any linear function, the average rate of change over any length input value interval is constant. Don't forget, when we're talking about input values, we are talking about the x values. So if you pick any interval in your graph, you will find that the rate of change will always be the same no matter which set of values you pick. We did that in Algebra 1, we did it in Algebra 2 when we were finding the slopes of the lines that were represented by the letter M. Um, Also, the rate of change of the average rate of change will always be 0 in a linear function. We often think of this as the slope of the line. Again, rate of change and slope mean the same thing. I'm going to explain this a little bit more by looking at a table of a linear function. So basically what I'm going to do is I'm going to look at the change in the x values, and then I'm going to look at the change in the y values, because that will determine the average rate of change of the function. So if you look on the left side, you go from 1 to 2 by adding 1, you go from 2 to 3 by adding 1, and then you go from 3 to 4 to adding 1. So that's going to be your change in the input values or your x values. If you look at the y, to go from 7 to 9, you add 2. From 9 to 11, you add 2. And from 11 to 13, you add 2. This column right here represents your average rate of change. If you look at the definition at the top, it's telling you that the average rate of change of a linear function is always going to be constant, meaning it will be the same number. Or you can think of it as there is no change when you're comparing one rate of change to the next one and to the next one. That's what that 0 represents on here. When you look at a quadratic function, it's going to be different. For any quadratic function, the average rate of change over any length input value interval is not constant, but it does tell you here that they're going to have a linear pattern to them. Also, the rate of change of the average rate of change will be constant. Let's look at the table at the bottom so you can see what I'm talking about. So same thing on the left side. To go from -3 to -2, I'm going to add 1. From -2 to -1, I'm going to add 1. From -1 to 0, I'm going to add 1. And then from 0 to 1, I'm going to add 1. If I go on the right side, to go from 7 to 2, I'm going to subtract 5. From 2 to -1, I'm going to subtract 3. From -1 to -2, I'm going to subtract 1. And then from -2 to -1, I'm going to add 1. If you look at the numbers, they are not constant, but they do follow a linear pattern, because to go from -5 to -3, I'm adding 2. From -3 to get to -1, I'm adding 2. And then from -1 to +1, I'm adding 2. So again, if you look at the pattern in the numbers, they follow a linear sequence. And when you look at the difference between the rate of changes, you do get the constant that is talking about here at the top. This is the first example. It says the table above gives selected values for the function f of x. Explain why f of x is not a linear function. Some important information that they gave you. They already told you that f of x is not a linear function, but they want you to explain how we can use what we learned previously about linear functions to give your explanation why you know that the table does not match the descriptions that we talked about at the beginning. So again, I'm going to look at the left side and then see the change in x's. So to go from 1 to 2 is +1. To go from 2 to 4 is +2. To go from 4 to 8 is +4. Since we're talking about a linear function, the changes on the left don't really matter, because it will be the same number no matter what the intervals are. To go from 4 to 7, I'm going to add 3. To go from 7 to 10, I'm going to add 3. And then to go from 10 to 13, I'm going to add 3. If we look at the left side, the change in x's are going to be different. So this does not represent my rate of change. I do have to divide by the numbers on the left. So 3 over 1, 3 over 2, and 3 over 4. You can try to simplify, but on this example, we cannot simplify any of them. So even though the numerators are the same, since we are dividing by the change in x, I'm getting different numbers. So this is not a constant. So when I look at the rate of change, in order for me to have a linear function, these numbers have to be exactly the same based on the definition that we talked about earlier. So it does say that the average rate of change over any length input value on the interval is constant. So we can use that to write our explanation and say I know f of x is not a linear function because the average rate of change in f is not constant. Make sure you write your answer using that explanation that I just gave you. And again, when you're answering the questions, you want to reinstate part of the question in your answer, explaining what they want to know or what they're asking you. Example number 2 is telling you to consider the quadratic function g of x equals x squared. They're asking you to complete the table of values for g over the consecutive equal length input intervals below, and then complete the table on the right side. So that's what we're going to do. We're going to start looking at the table on the left, and then we're going to input our x values into the equation to figure out what the y values are. So the first x value is -3. When I input -3 into this equation, all I'm doing is taking -3 and then squaring it. So -3 times -3 will give me +9. So I know that's my first output or y value that I have to work with. Next, I'm going to input the next value into my equation, which is -1 squared. Again, it just means -1 quantity squared. -1 times -1 will give me +1. Next one, I'm going to continue the process. 1 squared, which is 1. 3 squared, which is 9. And then 5 squared, which is 25. After that, I'm going to do the change in x first. So to get from -3 to -1, I'm adding 2. From -1 to +1, I'm adding 2. From 1 to 3, I'm adding 2. And then from 3 to 5, I'm adding 2. I already knew that because they told me that I'm working with consecutive intervals of equal length input values. I am going to do the same thing on the right side. To get from 9 to 1, I'm going to subtract 8. To get from 1 to 1, I'm going to add 0. To get from 1 to 9, I'm going to add 8. And then to get from 9 to 25, I'm going to add 16. After that, I notice that these numbers are different. They are not constant. Don't forget this column represents the average rate of change. If it was constant, then I would have a linear function. Like I said at the beginning, they told me that it was a quadratic. So let's find the change in the rate of change and see if we notice anything. On the second column, to get from -8 to 0, I'm going to add 8. To get from 0 to 8, I'm going to add 8. And then from 8 to 16, I'm going to add 8. This is the part that we were talking about at the beginning of the video, about the change in the rate of change being constant. And again, if we look at these numbers, they follow a linear pattern. In this case, it just means that we're adding 8 to go from 1 to the next, 1 to the next, 1 to the next. You can use this property to predict other values for other intervals using the information provided below. So the question at the bottom, it says, what do you notice about the average rate of change over consecutive equal length input intervals? So we are going to talk about the average rate of change having a linear pattern Or we can talk about the change of the average rate of change being a constant. You can word it into a nice sentence like we did. This table here, you can use it to fill it in if you want, but I just kind of did the process on the side instead of doing it here and then having to rewrite all the stuff. But notice how these numbers match these numbers. So these numbers will be listed here if you want to use that for that. Example number 3, they gave us some selected values for different functions, and they're asking you to identify the function as either linear, quadratic, or neither. In the future, we will be working with other types of functions, but for this specific problem, they just want you to use linear, quadratic, or neither as your answers. So looking at A, I'm going to look at the table, and then I'm going to find the change on the left, or the input value. So from 1 to 2, I'm going to add 1. From 2 to 3, I'm going to add 1. From 3 to 4, I'm going to add 1. On the right side, to get from 0 to 1, I'm going to add 1. To get from 1 to 4, I'm going to add 3. And then from 4 to 9, I'm going to add 5. I know that it is not a linear function, because if I look at the rate of change, they are all different. I can divide them by 1 if I want to, but it doesn't really matter because they are the same numbers. This simplifies to 1, the second one simplifies to 3, and the third one simplifies to 5. If I look at the change in the rate of change, I notice that to get from 1 to 3, I'm going to add 2. From 3 to 5, I'm going to add 2. So again, the change in the rate of change is going to be constant. So I know in fact that example 3a is going to be a quadratic function. When you write your function, you can say f of x is a quadratic function because the change in the rate of change is constant. That's all you have to write, and that gives you a great explanation of how you know and how you can use today's topic to explain that you know that example A is a quadratic function. Uh, we're going to do the same thing for B. So plus 1, from 2 to 5 plus 3, and then from 5 to 10 plus 5. When we look at the G's, from 0 to 1 is 1, from 1 to 4 is 3, and then from 4 to 9 is 5. After that, we're going to be dividing the numbers. Divided by 1, divided by 3, and divided by 5. When I simplify this out, I am going to get equals to 1, equals to 1, and equals to 1. So these two columns are the same one. The one on the right is simplified, and this is just my average rate of change. When I look at the numbers simplified, I notice that all of them are exactly the same number, or you get a constant. So for B, I'm going to say that g of x is a linear function because the average rate of change is constant. Keep in mind, the other one we're talking about the change in the rate of change, which is different than this one because on this one we only did one column and we found out that the number was the same. Since the number was the same, we were able to determine that g of x is a linear function. I'm going to go into C and do the same thing again. From 1 to 3, I'm going to get plus 2. From 3 to 5, I'm going to get a plus 2. And then from 5 to 7, I'm going to get a plus 2. From negative 1 to positive 1 is going to be 2. From 1 to 2 is going to be 1. And then from 2 to 2 is going to be plus 0 or no change. Again, I can divide them by 2 if I want to, but I can already tell that these numbers are different. When I simplify them, I get 1, I get 1/2, and I get 0. So I know h of x is not a linear function, but if I notice the change in the rate of change, so the first one is rate of change, and then the other one is the change in the rate of change. So I can explain this two different ways. I can say the rate of change has a linear pattern, or I can say that the change in the rate of change is constant because I can see here 1, to get from 1 to a half, I need to subtract a half. And then to get from a half to 0, I need to subtract a half. So this is a constant that I'm talking about. Again, you can write whichever explanation you like better. Keep in mind that if you're doing a multiple choice question, you might see both of them in different questions, so it's always good to know all the wording. So now let's talk a little bit more about concavity. We talked about concavity in 1.1 a lot, so it's coming back, and then we're using today's topic a little bit more to go more into depth with how the rate of change is connected to concave up or concave down. So for concave up, the average rate of change over equal length input intervals is going to be increasing. We already know that definition from before, so we just kind of review. If it's concave down, the average rate of change over equal length input value intervals is going to be decreasing. And we're going to use these two definitions to look at tables. And then we're going to use the average rate of change to determine if you're concave up or concave down. So let's look at example number 4. And it's saying that you have selected values for the 3 functions. For each function, determine if the function could be concave up, concave down, or neither over its domain. So let's look at A. If we notice, they are equal length interval for all of them, so I'm going to check that very quickly. I go from 1 to 1.1, and then from 1.1 to 1.2, and then from 1.2 to 1.3. So that all my x's are the same on all 3 tables, so I'm not going to worry about that. I'm just going to go into the y values and start working with that, and then I'm going to divide by 0.1 on all of them because that's my change. 0.1 plus 0.1 plus 0.1. So for the first one, to go from 4 to 1, I'm going to subtract 3. To go from 1 to -1, I'm going to subtract 2. And then to go from -1 to -2, I'm going to subtract 1. After that, like I said, I'm going to divide by 0.1 on all of them, and then I'm going to simplify. So the first one simplifies to -30 after I move my decimal, second one -20, and then third one -10. So this is the rate of change. And then looking at the rate of change, I notice that the numbers are increasing because to go from -30 to -20, I'm adding 10. And then to go from -20 to -10, I'm adding 10. Based on the definition, all I care about is what the change in the rate of change is doing. Is it increasing or is it decreasing? Since this number is positive, I know that the average rate of change as I go from left to right is increasing. So I know that my k of x function is going to be concave up. I am going to do the same thing for b. I'm going to make this a little bit quicker since we already kind of went over A very slowly. So to go from 1 to 4 is going to be +3. To go from 4 to 7 is going to be +3. And then to go from 7 to 10 is going to be +3. Again, divide by 0.1 on all of them. So this is going to be 30. This is going to be 30. And this is going to be 30 when it's simplified. I notice that this is actually a linear function because the rate of change is constant. Linear functions do not have concavity, so you can use that to write your explanation. And say m of x is neither concave up, neither concave down, because the rate of change is constant. That's all you have to say. I was just making a distinction since that was part of our lesson, that this is a linear function. And then I'm going to do the same. So now let's look at C. For this one, when I go from 1 to 7, it's going to be +6. When I go from 7 to 11, it's going to be +4. And then from 11 to 13 is going to be +2. Same thing here, plus 0.1, plus 0.1 plus 0.1. I'm going to continue dividing by 0.1, and then I'm going to simplify. So this is going to be 60, this is going to be 40, and this is going to be 20. So in this one, I am going to have concavity because the numbers are not the same. They are constant. They are changing. To go from 60 to 40, I subtract 20. And then to go from 40 to 20, I subtract 20. If I look at the change in the average rate of change, I see that the numbers are decreasing. So this p of x function is going to be concave down. And that's all I have to say. I did want to go over an example from the College Board. Okay, so we're going to start by reading the question. It's telling me that the average rate of change of a quadratic function p is -4 over the interval 0 to 2, and then -1 on the interval 2 to 4. And they're asking me what is the average rate of change of p over the interval 6 to 8. I am going to make a note of some important information. They did tell me that I have a quadratic function, so I can use some of the properties that we have discussed in the video to figure out what the answer is. They also gave me two domain intervals and the corresponding rate of change for those intervals. If we notice, we know that the first one goes from 0 to 2 and then 2 to 4. So they are going to be listed on my table that I'm going to create, like I said. So what I'm going to do is I'm going to say the first one is 0, 2, 4, and then 6, and then 8. I know they didn't give me any information from 4 to 6, but I can use the properties to find what the rate of change is from 4 to 6. And then, like I said, I'm going to create my table. On the left side, I'm going to put my domain intervals or my inputs. And then on the right side, I am going to put the rate of change between the numbers that was given to me. So they told me between 0 and 2, my rate of change is -4. And then they told me that between 2 and 4, my rate of change is -1. After that, since they told me that it is a quadratic function, I know that the change in the rate of change is going to be constant. So to go from -4 to -1, I do need to add 3. So I know that the next time that I see that, I am going to have the same constant, plus 3 throughout the whole graph. And I can use that information to figure out the missing points on the rate of change column. So I have from 0 to 2, 2 to 4, I need to find 4 to 6, and then 6 to 8. So I need to find the two missing numbers, and I can do it by adding 3 to the previous rate of change to get to the next one. So since the second one was -1, to get from this one to this one, I need to add 3. So -1 plus 3 will give me 2. And then same thing will happen on the next one. To go from this one to the next one, I need to add 3 again. So 2 plus 3 will give me 5. So C would be the correct answer based on the properties of quadratics. Thank you for watching this video. Hopefully you learned something new and have a good day. Thank you.